So it's Friday the 5th of February and it's time for physics fun. So I'm here in the lab and I've got a DC power pack set to 12 volts. Plugged in is a ray box, you can see. I've got a piece of card that I folded over and under. I've got a lens. In actual fact it's a convex lens. So it sort of bulges in the middle and it bulges on both sides if I go in. Small piece of blue tack, and I'm projecting through, if I turn slightly, I've made this triangular gap in the card there, and I'm projecting, you can see, onto a screen. Now then, if I zoom in on the screen, it's a little bit hard to see, but I'm hoping what you can see there, if I can get in, it goes a bit blurred with my my camera, but I'm seeing the actual curls on the filament lamp. I think we just about saw it in focus for a second. Let's try and get it. Might go a bit closer and get it. No, we're struggling on our focus. Pull it out a little. Now the idea of this video is really that you try this out, not that you get the wow factor from what I'm showing you. So what you want to do is try this out in class with a real filament lamp. And if you note, if I move the cable, I can twist the bulb. So what we're seeing is the metal armature and the wire. And for me, it's in perfect focus. Now then, our theory is actually relatively straightforward. So the formulas that we're thinking about is the distance u from that lens. So with us, it's not the edge of the ray box, but actually it's the exact position of the filament. So from the filament to the lens is u, from the lens to the screen is v. If I measure the two distances, 1 over u plus 1 over v is 1 over the focal length. And for this particular example, because u and v were 1 over actually, were 1.4, 3.6, 1 over f is 5, and so the focal length for the lens is 0.2 meters or 20 centimeters. So for mine here, if I work out my distances I measured from, like I said, the filament to the lens, and then all the way on my calculator. It's a really simple action now. Just get my calculator screen in. So I'm going to do 1 divided by 0.125 plus 1 divided by 0.775 gives me 9.29, and then I use my x to the minus 1 button. So if you didn't see that, it's this top one here, and I get an answer of 0.1076, which is 0.1 meters. Now I cheated, I'm afraid, and actually if we look, it came out the packet, the focal length of this lens is 0.1 meters or 10 centimeters. So we've just seen an experiment there on how to work out the focal length of a lens. Now the second experiment that you could try is if you move this lens different distances and you move the screen different distances, you could also look at getting the triangular part in focus. I might just see if we can quickly show that. Might not be enough. Might be difficult with the light level. So I'm moving my lens now, and then on the screen you can see that my triangle moves about, and I'm trying to get it really sharp. But there we are. Focusing power of a lens, convex, with animated science.